Okay, so next step is we have to start laying some tracks. Just looking at it, I want to do a couple of small adjustments. One is I want to move everything up. Now I'll just switch that to, let's make it 1 millimeter. And we've got our filter is set at footprint and tracks just footprint at the moment. I'll just do Windows select of all footprints and move them just one notch up, just making sure that we are away from the edges. We're not too close to the edge. I can adjust it a little bit further just by going those two footprints. I can move them closer and up a little bit. This one here, a little bit closer there, and I want to keep it on that level so I can run track next to that connector there. And okay, so for now this is good, it's okay. Let's start with just removing all those names and values, because we don't need to see them. We just need to see designators. It just makes the our job a little bit easier, cleaner. So what we'll do is we'll just save the board, go edit text and graphics properties. I want to change values, so I'll select in the scope, you select values, and the action, you just turn them off. So visibility off for values. So this is two things. You've got this has to be ticked on, and then you deselect that, and I'll just say OK. You can see that all our descriptions are gone, designators stayed in. It's just much cleaner, much easier to read. So I'll save this. And let's start with our communication tracks, because they are the most important ones, or the most critical ones at this stage, as far as we know. So I'll come closer, and there's two things we need to do first. First, well, let's just check that we are on the top layer. Yes, front copper, that's correct. Our grid and snap, we have to change that from 1 millimeter to, I usually route everything on 0.25, and then I can adjust it later at finer settings if I need to. So 0.25 is fine. I'll make sure that my selection filter is on footprints and tracks. Nothing else. I don't really want to select anything else from there. And I'll go to route tracks, and I'll start with my first track. Now, that one, it highlights your pins, it shows you directions. It's semi-intelligent. It does a lot of sort of funny stuff, avoiding obstacles and so on for you. You can just write it directly like this. You could route it sort of in parallel like this. But what I'll do is I'll just run it directly here, and the second one there. Now, this is not the most pretty. Those two tracks normally run them in parallel, but because of that distance, it's so short, it doesn't really matter. We can run it easily like that. There's no issue there. What we want to check, though, is that our track lengths are similar, saying that this communication, it's 3 megabits per second communication, which means that we could be off by a few centimeters in the track length, and that's not going to affect communication. Normally, with high-speed traces, yes, you run them parallel, you make sure that they're the same length. In this case, it's not as critical, although we will sort of check and verify that we've got similar length traces. So next, I want to run trace from that point to our pin. Now, coming into the processor, you have to be careful, because we don't want to come in on the side there. We want to come in face on, and sometimes the grid will not exactly snap into those pins depending on the positioning. So what I'll do is I can just run it like this, pretty much straight. Click there and just press enter. So I finished this track right there, and now I can restart that track from the other end and connect to this one. Done. So that's connected. Once it's connected, you can actually select that segment and move it. or if you can do something else with it. So I'll just leave this one as it is. Now, a second one, again, what I'll do is I'll just select the track again, run it in. This is close, sort of close, but not close enough. So what I'll do is I'll just do a little bit of a straight segment, click enter, and then restart it from the other end and connect. Now, technically, we want to have them close to each other. So what I'll do is I'll just hit escape to get out of the command, and I'll just move those a little bit down and leave it at this configuration. Now, lengths, you can check them. There's a few different ways of checking them. I like to actually use this tool, tune length of single track. I'm not going to use the tool, but I'll use it just to check the lengths. So what I'll do is I'll click on that, go over this track. It's 8.5 centimeters, or 8.5 millimeters. This one is 7.5, so there's a millimeter difference. That one is 8.7, that one is 905. So there's a little difference in that length. If we want to make them a little bit more even, what I'll do is I'll hit escape. I can actually move that segment out a little bit and now remeasure that. Like as I said, in this case, that's not as critical. So this is 8.5, this is 8.48, so they're almost identical. The only thing is we are coming on the side of that pad there. That's not a good practice for small components. The solder may actually skew the component when you're soldering it on. So what I'll do is I'll move this below. Maybe something like this. Okay, and that's a little bit better. And in this case, yeah, I want to come up like this. Look, it's not exact, the lengths. This is 9.1, this is 8.6. Look, I can live with that. If we really want to make it a little bit closer, we can reposition those components, we can play with it, but with those communication speeds, it doesn't matter. We are still good. Since we are here, okay, I'll just run the communication tracks first. So next, we've got a couple of pins there connecting to our TXRX pins over here. And if I run them on the inside, and I'll just zoom in, inside, I can run out like this and then connect it here. And then the second one, I can connect it right there. Now, technically, I want to make them similar lengths. So what I'll do is I'll just connect it through here. What I'll do is hit escape. That one there, I'm actually going to make it a little bit longer. Depends how long do you want to make it. And let's just test it and see. This one is 12.1, this one is 10.1, so it needs to be a little bit longer. And what I can do is I can actually bring this one much closer, so they're just next to each other. And test it now. 11.3, 12.8, minimal difference, that's all good. Now, what we have here is we've got 5 volts coming here. We can come from the outside, which means there's no issue with that space being closed. We also have those unconnected pins, that's fine. We just need to make sure that we connect this ground plane to a common ground, and the same on this end. So we could either create this one a little bit larger space, just to make sure that we can put ground stitching via through those 2 areas, or we could space them up so it just floods that whole area, the ground will flood this area, but I'll leave it as this. So that's okay for communication side. Now, we still need to connect to our microprocessor. And again, I'll just run those two tracks in the simplest possible way. Saying that, I want to make sure that they reasonably equal in length. So I'll start with the RX. And how am I going to run this? I'll probably run it a little bit higher because I've got this pin. Yeah, okay, so I'll run it here somewhere and connect it there. Now, with that little kink there, we don't need it. So what I'll do is I'll just select the two again. And yeah, it doesn't want to go the other way. So let's try going from this end. That's it, and it's fixed. Now, sometimes you can delete those segments and just put them back in. You just want to have a nice, uncomplicated track. Now, the second one comes from here. So what I'll do is I'll bring it back closer to this one. So maybe as close as this. Run them in parallel and connect it through there. When it comes to the lengths, that one is 20.25, this one is 18. Small difference. If you really want to make them equal, you just move those two segments up a little bit, extending this one out. But in this case, I don't believe there's an issue and need to make them equal length. So that's done. So this is the track which is communication critical. We always slide them first. We make sure that we don't cross to the other side of the board. You want to have them on the same side to direct through it, reasonably equal length. Now, obviously, there will be some other tracks which may be also used as communication tracks. And what we're talking about is, all those pins, they connect to input-output pins from the micro. They go into those external pins. You may have a device plugged in and you may want to communicate with some reasonable speed there, which means, yeah, they also high priority, but we don't know. So this takes priority. We just light our RxTX first, and then we do the best we can with all the other pins, which are input-output pins. But before we do that, let's just look at the power. We need to supply power to this board. The power will be run on the top as well. So we are just working on the top of the board. Bottom doesn't interest us at this stage. So if I select the track and go from, zoom in, this is our power pin. And notice that my track width is already much thicker. This is 0.5 mil. The reason for that is that in the schematic we actually put in the allocated this this net to a power net, so it knows that it has to be thicker. So what I'm going to do is I'll just come down here somewhere, connect to my V bus here, and now those two capacitors, I just connect them to that track. Okay, so this is the main power comes through there. It's filtered by 2 capacitors and FB, which I've forgotten what it is, and ferrite bead. And now we can run that to the rest of the board. So there are a few different schools on how to do that. One school is you go to the bottom layer and you run it through the bottom. I don't like it because it splits the bottom layer, supposed to be ground plane, mainly ground plane. You want to use only short bridges on the bottom. You want vast majority of your tracks to be on the top. The reason for that is you need a uniform ground plane to make sure that there are no sort of trims and currents coming through different pins in different directions through your ground. You just want to have it as stable as possible. So the main power, I'll run it in a loop. So basically, I'll just go with this power all around the board to make sure I can power all my devices through that one loop. So let's just go for it. From here, I can cut across. You can see all the pins, highlighted pins, which will need power. So I'll just run it in between those two, and I really don't like when this starts going wobbly like this. And okay, and I can either continue on, which I can do. I can just continue on. Select. I want to go around. And yeah, I could run it back to this one, the main power all around here. But in this case, I'll probably finish it here. You can do a full loop. It's it's good to have a sort of a power loop, but in this case, I'll do not fully closed loop. So I'll just run inside of that chip there. So what I'll do is I'll just run. I'll just run it like this and try to connect there. Now this connection there, it didn't actually work simply because that track is too wide. So what I'll do is I'll hit escape. I'll select that little segment there, delete that one. This one I can keep, and I can connect this 5 volt into that main track, this main carrying track, through a thinner connection, because that's 0.5. It's way too wide. It doesn't fit there. So what I'll do is I'll change my track Usenet class. Okay, I'll change that to, let's say, 0.25, a standard track width. And now I can run my power track using different different net width and connect it through there. So and this is perfectly fine method. You always should sort of, to verify connections, use a thinner segment of a track to connect into a bigger track. Okay, now also those connections through there, 5 volt, you can see it's on this side where this connects to that, which means we need to actually rotate those two. So what I'll do is I'll hit escape. And I'll just leave it as that, because we can do this as in the next step. So power comes in, gets filtered, goes around. We can clean this up. Yeah, just a sharp corner there. I can cut through a little bit deeper in there. It really depends how you want to run it. I run around here, so yeah, we're all good. We are spaced out from those two connectors. Okay, so since I'm doing power, I may as well connect my main power pins. So pin 9 is always the 5 volt, and I'm going to use a full track width. So I'll change that back to Usenet class. And then go from that pin, connect my main power. I can do the same here, 5 volt, connect. I can do the same here, 5 volt, connect. And we need one here. And well, I'll just go around because that's a ground plane there. So what I'll do is I'll go 5 volt, come out, come down. I don't want to connect here because that's too close, so I'll just kick it in a little bit and connect through there. Okay, so we are supplying power to all those connectors. We still need to supply power here to our FTDI chip. There's a second 5 volt input there. So what I'll do is I'll just run. This one can be thin actually. It's not a big distance, so you could easily just use 0.25. But what we could do is, yeah, that's what I'll do. I'll just change to 0.25 and just go from here, just connect there, done. Okay, and what else do we need to connect? Micro. Now, running power to micro is a little bit more difficult because we've got all those tracks internally sort of wired up, and they have slightly higher priority. So what I'll do is I'll leave this part powering up that 5 volt. I'll leave it out until the end, and then we'll see how we can actually supply power to this. Let's escape. How we can supply power to this micro. But we've got most of the devices have power connected. So let's have a look at the next element here. We need to connect those to grounds. So what I'll do is I'll hit escape, and maybe I'll just move this. I can move it right out actually. Yeah. Use my net connection, and this connection doesn't have to be too thick. There's no current coming through as such. So what I'll do is I'll connect it like that using thin track. It's ground, but it's different ground to your board ground. That's why we're using the connection. That ground is the same as the board, so we don't have to manually allocate it. It will automatically join everything together. The system will. So this part is done. Let's have a look at our diodes, the communication diodes. And I can see that we've got our pins are crossing right there. So escape, our connections are crossing, which means that what I'll do is I'll just move those 2 components. I'll move them to the top. Those 2 components, I'll move them, I'll move them to the bottom. If we swap those components, then we've got tracks will not cross. So we can do this part. And also, okay, I need to rotate those 2 because 5 volt is on this end, that connection goes here. So I'll just select that, press R twice, and now I can connect my pads. And now I have to run to those pins. So what I'll do is I'll run this across, and yeah, I can connect it right like this. That's not ideal situation there. So what I'll do is I'll clean it up a little bit. Yeah, just like that. And now the TX, it doesn't really matter how it, how it's routed, the way it goes. But what I'll do is I'll just bring it closer to this one and just run it in parallel to connect. So this is all wired, except for the ground. Actually, there's no ground here, this is just power. So I can easily now connect those 2. Okay, now I didn't change this to use net class, but we are 0.25, which is our net class for signal anyway, so I'll change that back. But we are connected through there. Since we are in the system, we want this capacitor to connect to 5 volt and be close to it. So I'll move that one a little bit closer, and I'll just connect it from 5 volts. We want connection there. You don't want diagonal connections. It's bad practice. The system should understand that, but it doesn't. So what I'll do is I'll connect through the end. Now, why do we actually route it from to the back of the component all the time, not to the side of it or on angle? The reason for that is that that copper might pull, depends on your clearances and gaps. The solder, while you're soldering, if you have track coming on the side, and especially if you have skewed situation where one track comes on this side, the other track comes on the other side, those 2 tracks will pull solder in a little bit, and they might actually skew the component. So it's not a huge issue. You can still solder it in most cases. But a good practice is always to come from the end of the component into the pad and not from the side. Same for those end pins, definitely run them from the ends, don't do sides. That's the good practice rule. Now, 3.3 volts, we can again just connect it through there somehow, and that's done. So as you can see, we've got this part of the circuit on this side completely connected with no crossing to the other side. We've got no lines crossing, nothing is crossing, everything is good. So you always try to save this. You always try to route it out so you've got all direct connections, you don't have any lines crossing, you don't go under the board, over the board, and do all sorts of tricky things to cross those lines. We'll have to do them in here, but we didn't have to do it in there. So let's just do the other end, which is an easy end as well. And in this case, yes, again, we've got those resistors, they need to be rotated, and those LEDs need to be rotated. So I'll just select that one here and just press R twice on each component to make sure that they are the orientation is correct. Okay, and now we can run tracks through them. So I usually start in the middle and go out. Let's just connect. We'll do direct connections first, the easiest one. So we've got our Usenet class, which is 0.25. We do everything using the same thickness on this board. Nothing too fancy. Okay, and now I'll just run it from the center. So let's say I'll start with pin 4, and I need to run it there. Now I don't like this sort of configuration, so I'll just go out and in. Same with that one. I'll make sure that we're coming in into those pins. Now that one could be like this, but I'll probably offset it a little bit, just like that. And now, and the last one, I'll just do the last one. And now we can optimize it a little bit. So I'll just hit escape, zoom in and go, okay, that one, I can bring it a little bit closer to minimize the track lengths. Not that it matters in this case, but they're just LEDs. Yeah, that's okay. That's okay. So now I can continue on below. Okay, if you see something like this, you can usually sort of fix it by just either deleting. I can just select and hit delete button, delete those two, and use direct connection from here to there. Oh, okay. It didn't trim it automatically. It should. So I select it and press delete. That's okay. I can optimize it a little bit by bringing this a little bit closer here, and this one a little bit closer there. So technically, we could probably even run this right across. So what I'll do is yeah, that's nice. Let's come from here. It's trying to play tricks on me. So what I'll do is I'll break it into segments so to force it to go certain ways. Cancel. No, that's okay. Next one, I want to go out here, and then I want to go like this. And I want to clean up that corner, so just come from here, and yeah, I'm trying to force it to go the other way. Can't. Let's just see if I can force it. No. So what I'll do is I'll delete those two. There's probably an easier way of doing it, but it's not that hard to fix it. Okay. Again, I'll just cancel, bring it in a little bit, done. Okay. I can either leave those gaps bigger so the ground plane floods through it, which is probably a good idea here. We still have reasonable clearance here to 5 volts. You can move it aside a little bit if you want to. We can sort of adjust. Oh, I double click too quickly, but I'll just leave some bigger gaps to make sure that my ground plane floods through in between those tracks. So this is it pretty much. This side is done. Maximize it. So I'll just break this recording, and then we'll just start looking at the center bit. So everything from those pinouts to microprocessor.